Hello everyone, welcome to the session on digital electronics. In this session, we'll be discussing about one of the most popular flip-flops called as JK flip-flop. In this session, we will see how JK flip-flop can be constructed by using SR flip-flop. We will also see how JK flip-flop can be constructed by using NAND gates. We will see the truth table of JK flip-flop. We will also see the age-triggered flip-flop, the race around condition, and how JK flip-flop can be used in different forms. Friends, as you know that you are viewing this session on my YouTube channel Learn with Prakash Khanade, and subscribe to the channel to see many videos on the subjects of electronics and computer science. So let us start the session how we can construct the JK flip-flop by making the use of SR flip-flop. Now, in case of SR flip-flop, we know that when S is equal to 1 and R is equal to 1, then this state is not used in SR flip-flop. This is because both the outputs Q and Q bar of SR flip-flop will try to become same, and this is against our logic, and therefore this state is not used in the SR flip-flop. So you can say that this is a kind of a problem with SR flip-flop, and this SR flip-flop problem can be resolved by using JK flip-flop. So it is possible that we can modify SR flip-flop into JK flip-flop by using the connection such as S is equal to JQ bar and R is equal to KQ. So as shown in this diagram, suppose I have been given a SR flip-flop, then I will need two more AND gates. First AND gate will have the input J and another input will be Q bar, and its output JQ bar will be connected to the S input of SR flip-flop. Another AND gate will have the input K and its another input will be Q, and its output KQ will be connected to the R input of SR flip-flop. So when we make such type of the connection, then the flip-flop that is being constructed is being called as a JK flip-flop. So we can draw the symbol for the JK flip-flop, which is similar to that of SR flip-flop, except one change, that the inputs are now labeled as J and K, and there will be a clock input, preset input, clear input, and the outputs will be Q and Q bar. Now, by using the two AND gates and one SR flip-flop, it is possible that we can construct the JK flip-flop. Now, when we look for the truth table of this flip-flop, then we can construct the truth table for the JK flip-flop. When J is equal to 0, K is equal to 0, then output of both the AND gates will be equal to 0. And therefore, S will be equal to 0, R will be equal to 0. And according to the truth table of SR flip-flop, there will be no change in the output of the flip-flop, that is Qn plus 1 will be equal to the initial state Qn. When J is equal to 1 and K is equal to 0, then here we need to consider the possibility of initial output Q is equal to 0 or 1. And in such a case, one can easily observe that the output of the second AND gate will be equal to 0. And the output of the first AND gate will depend upon the initial output Q bar. So if it is 0, then the S and R both will be equal to 0. If it is 1, then the output of the first AND gate will be equal to 1. And therefore, S will be equal to 1 and R will be equal to 0. And therefore, the output Qn plus 1 will be equal to 1. So this is the set condition of the JK flip-flop. When J is equal to 0 and K is equal to 1, then the output of the first AND gate will be equal to 0. That is, S will be equal to 0. But the output of the second AND gate will depend upon Q. If Q is equal to 0, then R will be equal to 0. And therefore, in that case, you can say that S will be equal to 0, R will be equal to 0, and output Q continues to remain 0. But if Q is equal to 1, then the output of the second AND gate will be equal to 1, and therefore S will be equal to 0 and R will be equal to 1. And therefore, according to the truth table of SR flip-flop, the output Qn plus 1 will be equal to 0. That is, this is the reset state of the JK flip-flop. Now, when we consider both J is equal to 1 and K is equal to 1, then one can easily observe that the output of both the AND gates will depend upon the initial output. If Q bar is equal to 0, then the output of the first AND gate will be equal to 0. And the output of the second AND gate will be equal to 1. Therefore, S will be 0 and R will be 1. And therefore, in that case, one can easily observe that the initial output will get changed to the complement of the initial output. That is Qn plus 1 will be equal to Qn bar after the application of the clock pulse. The same state can also be verified if we consider the initial output Q is equal to 1 and Q bar is equal to 0. Now, when the initial output Q is equal to 1, then one can easily observe that the output of the second AND gate will be equal to 1. That is, R will be equal to 1 and S will be equal to 0. And therefore, in that case, the initial output 1 will be changed to 0 after the application of the clock pulse. And therefore, one can say that when J is equal to 1 and K is equal to 1, the output Qn plus 1 is complement of the initial state, Qn bar. And therefore, the problem of SR flip-flop, when S is equal to 1 and R is equal to 1, then both the outputs Q and Q bar try to become same. This problem of SR flip-flop is being resolved in JK flip-flop. And therefore, this state now can be used in the circuit whenever we make the use of the JK flip-flop. It is also possible that we can construct the JK flip-flop by using the 4 NAND gates. Now this JK flip-flop will have the two inputs J and K, and actually these inputs are named after its inventor, Jack Kilby. So by using 4 NAND gates, we can construct the JK flip-flop as shown in the figure. The gate G3 will have the J input, the gate G4 will have the K input. Another input of G3 and G4 is being made common, and it is being called as a clock input. One input of G3 is connected to the Q bar, and another input of G4 is connected to the Q. The preset input is connected to the gate G1, and the clear input is connected to the gate G2. So the symbol for the JK flip-flop will remain the same. That is, it will have the inputs J, K, and clock, and also preset and clear. Preset and clear inputs are active low, and therefore a bubble is used in the diagram of JK flip-flop, and the outputs will be Q and complement of Q. Now the truth table for this flip-flop will remain the same. That is, whenever J is equal to 0, K is equal to 0, then the outputs of the gates G3 and G4 will be 1, irrespective of whatever may be the initial output. And therefore, there will be no change in the initial state of the flip-flop. That is, Qn plus 1 will remain Qn. That is, the initial state will be continued even after the application of the clock pulse. When J is equal to 1 and K is equal to 0, then the output Q will be forced to set to 1. Even if it is initially 0, it will be changed to 1. And therefore, this state is being called as the set condition of the JK flip-flop. When J is equal to 0 and K is equal to 1, then the output Q will be forced to 0. That is, even if it is 1 initially, the output will reset to 0 after the application of the clock pulse. And therefore, this condition is being called as the reset condition. And when J is equal to 1 and K is equal to 1, then the output will get continuously toggled. That is, whenever we apply the clock pulse, if initial output is 0, then it will become 1. And if the initial output is 1, then it will become 0. And therefore, this state is being written as Qn plus 1 is equal to complement of Qn. The problem with any flip-flop is that if the clock pulse is high for a long duration of time, then it is possible that the input data may get changed over a period of time. And therefore, we are not sure what exactly the data is being stored in the flip-flop. And therefore, it is necessary to modify the circuit of the JK flip-flop so that we can store the data at particular instant. And such flip-flop being called as the age-triggered flip-flops. That is, in age-triggered flip-flop, either we can store the data at the leading edge of the clock pulse or at the trailing edge of the clock pulse. So even if the clock pulse is high for a high duration of time, it will not have any impact on the data storing. So age-triggered flip-flop can be constructed by making the use of RC differentiating circuit, and this circuit is to be connected to the clock input of the JK flip-flop. Now, whenever we connect the circuit, then we need to take care that the RC time constant must be kept smaller than the pulse width. So suppose I have been given a JK flip-flop, and to the clock input, I will connect a RC differentiating circuit where the capacitor C is connected in series with the clock input and resistance R is being connected in parallel with the clock input. Now, whenever we apply a square clock pulse, then because of this RC differentiating circuit, we will generate the two spikes. One spike, positive spike, will be generated at the leading edge, and negative spike will be generated at the trailing edge of the clock pulse. And therefore, it is possible that we can store the data either at the leading edge or at the trailing edge. So whenever we are storing the data at the leading edge of the clock pulse, then such symbol is being used in the JK flip-flop. If we are storing the data at the trailing edge, then here we will make the use of one bubble indicating that the data is being stored at the trailing edge or falling edge of the clock pulse. So there is no change in the truth table. So in the age triggered flip-flop, the truth table of JK flip-flop will remain the same. That is, when J is equal to 0, K is equal to 0, then Qn plus 1 is equal to Qn. When J is equal to 1, K is equal to 0, then the Qn plus 1 will be equal to 1. When J is equal to 0 and K is equal to 1, the output Qn plus 1 is equal to 0. And when both the inputs are 1, then the output is complement of the initial state. There is one problem that is being commonly observed in JK flip-flop, and this problem is being called as a race around condition. In JK flip-flop, we have seen that when J is equal to 1 and K is equal to 1, then the output of the JK flip-flop will go on toggling. That is, if the initial output is 0, then after application of clock pulse, it will become 1. And if it is 1, then it will toggle to 0. But suppose the clock pulse is made high for a long duration of time. If the clock pulse is high for a long duration of time, then we will find that the output of the JK flip-flop will go on continuously changing after a certain small amount of time called as delta T. That is, the output will race and the output will be uncertain at the end of the clock pulse. So we are not sure what kind of output we will get, because after every short duration of time delta T, the output of the JK flip-flop will get toggled when the clock pulse is high for a long duration of time. And this condition is being called as the race around condition in JK flip-flop. So as shown in the figure, suppose my pulse width is quite higher, and after a time period delta T, the circuit will change its state. That is, if it is initially 0, then it will change to 1. And suppose still the clock pulse is high, then the circuit will again change the state and it will again become 0. So this goes on continuously, and therefore we are not certain about what kind of output we will get after the application of the clock pulse. And this condition is being called as a race around condition because the output is in kind of a race, and therefore it must be avoided. So it can be avoided if we can make the width of the clock pulse, which is smaller than the time period delta T, where this time period delta T is the time required for the electronic circuit to change its output. And this time period is very small, and it is in microseconds, or sometimes it is in nanoseconds. So making the clock pulse very small is very difficult practically. So another way to avoid the race around condition is that you can make the use of JK master slave flip-flop. So instead of using one flip-flop, we can make the use of the two flip-flop. One flip-flop is there, and the output of the first flip-flop is connected to the input of the next flip-flop. So there is one master and there is one slave, and therefore such flip-flop is being called as a JK master slave flip-flop. So this is the best way to avoid the race around condition. So instead of using one flip-flop, we can make the use of the two JK flip-flop in JK MS flip-flop. The output of the first will get changed during the leading edge of the clock pulse, and the output of the slave will get changed during the trailing edge of the clock pulse. And therefore, even if the clock pulse is high for a long duration of time, the output of the JK flip-flop will get changed only once, and therefore the race around condition can be avoided. Now we can construct the JK master slave flip-flop by making the use of the two JK flip-flop. As I told you, the output of the first flip-flop, which is called as the master, it will change at the leading edge of the clock pulse. and the second flip-flop is a slave flip-flop. Since it follows the first flip-flop, it is being called as a slave flip-flop, and its output will get changed at the trailing edge of the clock pulse. So as shown in this diagram, by using NAND gates, we can construct the JK master slave flip-flop, where you can easily observe that the clock pulse is directly applied to the first part of the flip-flop, which is called as a master. And the clock pulse is applied by making the use of the NOT gate to the second flip-flop. And therefore, the output of the first flip-flop will get changed only during the positive edge or leading edge. And at that time, the second flip-flop is disabled, and therefore its output will not get changed. So whenever the clock goes to an end, then only the output of the second flip-flop will get changed because it becomes enabled. And therefore, even if the clock pulse duration is high, the output of this flip-flop will get changed only once, and the race around condition is being avoided. So as far as the symbol of JK master slave flip-flop is concerned, one can easily observe that there is a small change at the clock input. We will put a bubble and a triangle. So it indicates that this is a age triggered flip-flop, and the output of this flip-flop will change only during the trailing edge. So whenever we make the use of the JK master slave flip-flop, then we can avoid the race around condition, and observe that the truth table of JK master slave flip-flop will be same to that of a JK flip-flop. So there is no change as far as the truth table is concerned. Only thing is that the race around condition is being avoided. So when J is equal to 0, K is equal to 0, output Qn plus 1 is equal to Qn. When J is equal to 1, Q is equal to 0, output is 1. When J is equal to 0, K is equal to 1, output is 0. And when both are 1, then the output is complement of the initial state, that is Qn bar. IC 7476 is a very popular IC, and this is a JK master slave IC. That is, it will consist of two JK MS flip-flop. So this is a very popular IC, and in practicals, whenever we need to make use of the JK flip-flop, then we can make the use of this IC. JK flip-flop can be used in variety of ways. Say one way of using the JK flip-flop is to convert it into D-type flip-flop, where D, it will stand for the data input. So just by connecting one NOT gate between J and K input, it is possible that we can construct the JK flip-flop. As I told you, the D input is being called as a data input. So whenever you want to feed continuously some data to a flip-flop in order to store it, then in such a case, you can make the use of this flip-flop. So as shown in this diagram, we have simply connected one NOT gate between J and K, and there is only one input D, and there we can apply 0 or 1, and such flip-flop is being called as a D-type flip-flop. So when D is equal to 0, then one can easily observe J will be 0 and K will be equal to 1, and therefore the output Qn plus 1 will be equal to 0. When D is equal to 1, then J is equal to 1 and K is equal to 0, and therefore the output Qn plus 1 is equal to 1. So one can easily observe that whatever the input that we apply, the same input will get stored in the flip-flop, and therefore this is being called as a data flip-flop. So output of the D flip-flop is same to that of input, but we will get the output only after application of the clock pulse. So the truth table is very simple, and it will have only two states because there is only one input. This flip-flop is a very popular flip-flop, and this flip-flop can be used in the shift registers. So whenever we want to store sequentially some amount of data, then for storing of this data, the shift registers are used where we can make the use of D-type flip-flop. IC 7474 is a very popular D-type flip-flop where there are two D-type flip-flops available. There is another way of making the use of the JK flip-flop, and this flip-flop is being called as a T-type flip-flop or toggle flip-flop. So T flip-flop is just nothing but a toggle flip-flop. This flip-flop can be constructed by making the use of the JK flip-flop. So here what you need to do is that you need to connect J and K together so that we can form the T-type flip-flop. The T input is being called as a toggle input of the JK flip-flop. So simply connect a wire between J and K and it will have only one input T, and such flip-flop is being called as a T-type flip-flop. So whenever the input T is equal to 0, then J is equal to 0, K is equal to 0. Therefore, output Qn plus 1 will be the same as the initial state Q1. When T is equal to 1, then J is equal to 1, K is equal to 1. And therefore, the output Qn plus 1 will be the toggle state, that is the complement of the initial state Qn, that is Qn plus 1 is equal to Qn bar. So the output will be complement of the input, and this will be the truth table, which will consist of only two states because there is only one input to the T-type flip-flop. So this flip-flop is also very popular, and this flip-flop can be used in counters. So whenever we study counters, then in those circuits, you will find that we will be making the use of T-type flip-flop. So thank you, friends, for viewing the session. Hopefully you have understood how SR flip-flop is being converted into JK flip-flop and how the JK flip-flop can be used in its different forms. So thank you all for viewing the session.